Alright, Sharon and Rhonda. Let's see what I can do to help you with truth tables. Alright, so I've got this little chart here. Now obviously the first thing you gotta know about truth tables is the rules. The table itself is pretty easy, but getting the rules down is hard. So you've got your not, your and, your or, your if then, and then your if and only if. So let's take a look here. Not P, the little squiggly, squiggly, squiggly. That's just going to be the opposite of whatever P is. Now the great thing about P and Q is they're generally the same. It's always true, true, false, false, true, false, true, false. Now what that shows is every combination that P and Q can have. It can be true and true, true and false, false and true, or false and false. So that gives you all those combinations. Now let's say we're looking at not P. Not P is just going to be the opposite of P. So we've got true, true, false, false, the opposite of which is going to be false, false, true, true. Understand? Not too hard. Now let's take a look at and. And truth tables are true if P and Q are both true. So and, true and true. Got it? So if we've got true and true, then P and Q is going to be true. True and false, false and true, false and false, all of those are false because they're not both true. Or, just like it sounds, either P or Q is true. So P or Q, there's a true, so that's true. There's a true, so that's true. There's a true, so that's true. There's no true in there, so it's false. Let's take a look at if then. If thens are kind of hard, but really when you think about it, it gets a little bit easier. If P is true, it's true if Q is also true. And if P is false, it's true no matter what Q is. Now, I'm not very great at explaining the reason for that, but if P is false, then the if isn't in place, so we don't care. It doesn't matter if it's true. So basically, if P then Q. P and true, P is true, so in order for if P then Q to be true, Q also has to be true. So that's true. True, but Q is false, therefore if P then Q is false. False, it doesn't matter, so it's true. False, again it doesn't matter, so it's true. So that's kind of the basics for the rules. I'll kind of freeze on that a little bit just to give you an idea, and you can take notes if you pause the video and whatnot. So you're good there. So let's do a quick example. The example, let's make a truth table for P and not Q. So the first thing we're going to do is P, Q. I know they're not supposed to be uppercase, but it's easier. Now we set it up the same way as every other time, so it's true, true, false, false, true, false, true, false. And that gives you all the possible combinations. True, true, false, false, true, false, true, false. Every combination. So then, ours is P and not Q. So the first thing you're going to do is get the outers. So our P, we're just going to copy directly from P. So P is going to be true, true, false, false. Not Q is going to be the opposite of Q. So instead of true, false, we're going to have false, true, false, true. So now if we go back to our and, which is our last step, is to figure out the and. Our and rule is true if P and Q are both true. So then we just look at this. P and Q. So true, false, they're not both true, so it's false. True, true, they're both true, that's true. False, 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 true is false. So unless they're both true, an and statement is false. So now that's our answer. So the truth table for P and not Q would just be false, true, false, false, just like we've got there. So the thing to remember is when you're looking at this statement right here, you're just basing it off these. You don't have to worry too much about that. These are just your references. You know that P is going to be exactly what P is, and not Q is going to be the opposite of Q. So then you just work from there. Let's see if we can do one more. Let's do if P, then not Q. Okay? So we set it up the same way. P, Q, true, true, false, false, true, false, true, false, That's just going to be the way you set it up every single time. So then we look at P, if then, not Q. And we do the same exact thing. We just copy over. So our P is going to be true, true, false, false. Our not Q is the opposite of Q. So instead of true, false, false, true, false, true. So then we just look at the rule for if then. What's our rule for if then? If P is true, then it's true if Q is also true. If P is false, it's true no matter what. So we've got a true here. We need to know if Q is also true. It's not. So that means it's false. We've got a true there. P is also true. So that's true. False? Well, we don't care, so it's true. False? Again, we don't care. It's true. So your truth table for if P, then not Q